I'm Megan Bang. I'm a software engineer here at HashiCorp, and I've been here for a little over 2 years now. I started working on the Google Terraform provider, where I'm still working, and recently I began working on the new Google Workspace provider. Today, I'm going to tell you about how the experience of starting on a major provider shaped the vision and design of the Google Workspace provider, how I used what I learned from the Google provider to quickly forge ahead through some of the otherwise more significant pain points of developing providers, and we'll finish with a look at some new things I learned as I was navigating the territory of building a provider from scratch. First and foremost, I want to really underscore how beneficial it was to have the experience of contributing to a pre-existing provider and learning from all the more experienced engineers on the Google Terraform provider team. By reviewing their code and collaborating with them on reviews of my code, I picked up a lot of unwritten best practices that I was able to carry forth when I started defining the Google Workspace design. Specifically, a great advantage of the Google Terraform provider is that the majority of our Terraform resources and even some of our tests are auto-generated using a tool called Magic Modules. Magic Modules was developed by the team at Google and consists of templates for Ansible, Inspect, and Terraform. Developers on our team populate YAML files that mimic the REST API specs, and Magic Modules fills in the templates from there to create the Terraform code. As with everything, there are periodically some customizations that we need to do to make all the APIs work nicely with Magic Modules, but even then, we have a well-organized way of handling those customizations that make things pretty uniform throughout the Google Terraform provider codebase. Let's be honest, having auto-generated code is a really helpful way to see the patterns of what the code needs to do, while also making sure function naming is clear and consistent across the entire codebase. This was a big thing I wanted to bring forward into the Google Workspace provider, as it's great for onboarding a new maintainer and maintainability in general. We didn't auto-generate any of the Google Workspace code, but we tried to follow similar patterns for each resource and data source. Prior to starting the project, we had done some research into whether we wanted to adopt the community-written G Suite provider or write one from scratch. We chose to write it from scratch so that we could implement the consistency of the code base, as well as there were a few things we wanted to implement differently. A main difference being custom schemas and user attributes. That being said, we found the community provider and much of its implementation very helpful. I'll speak to these things a bit later. So to begin, I created a new repository using the scaffolding provider template on GitHub. I browsed through the files a bit to get familiar with our scaffolding project, to see what I needed to customize for Google Workspace, and made those small changes first. The next thing I wanted to get working was authentication. I wasn't around for implementing authentication for the Google provider, so this was something I knew that I had to learn, but also I was very interested in how it worked. This was one area I was incredibly grateful for the community-developed G Suite provider. I was able to go between the Google provider authentication and that one and notice the differences and go from there. In the Google provider, there are a few options to authenticate. You can provide an access token, a credentials file, a user email for impersonation with either of those, or use the default token source. We use the OAuth 2 Google package shown here to authenticate. You can pass in the hard-coded token to a credentials object, or call credentials from JSON, which will create a credentials object for you. This is the typical and suggested use case. In either case, you can have the option to impersonate a user's credentials, so long as the service account is set up correctly. All you need to do is supply the desired user's credentials and an OAuth 2 Google option for impersonating credentials, and again, the package will take care of it. Scopes is also an option to be defined here, although by default, the provider has scopes set that you can do most anything. Google Workspace functions a bit differently. After discussing with the team at Google what needs to be set up, they pointed out that for the Workspace APIs, a user must be impersonated. and domain-wide delegation needed to be enabled on the service account. Unfortunately, domain-wide delegation can only be enabled in the console, so I got that set up in GCP, then headed over to the admin console where I needed to use the client ID that was generated by my service account and set it there along with all the scopes that particular service account has permission for. This differs from the Google provider, as the service account there is not limited to any scopes other than the ones defined in the provider. On Google Workspace, however, the OAuth scopes need to be set in the provider and in domain-wide delegation for extra security. So after I set that up, I attempted to copy and paste how Google read the credentials and added the impersonated user, but it still didn't work. The Google team said I needed to set the subject. However, I didn't see that option anywhere in the OAuth 2 Google options. I hopped on over to the community G Suite provider to see how they did it and saw the OAuth 2 Google package had a different function available, namely JWT config from JSON, which returns a JWT config object that has an option to set the subject. This is where I was able to add the impersonated user email. This config object creates a client, which we can then use throughout the provider. Once I got authentication working, I wanted to write some tests for it. I wrote them to closely resemble the tests in the Google provider, checking for invalid credentials, credentials stored in a file, and credentials stored as a string. I was able to get this working locally, then had to decide how to run them in my GitHub test workflow. So I switched gears and learned all the things GitHub Actions. Okay, not all the things yet. My knowledge of GitHub Actions is still very much a work in progress. Google credentials are stored in a JSON file. However, GitHub strongly suggests not storing sensitive information as a JSON object in its secrets. So my first action item was to figure out how my credentials would remain a secret without storing them in GitHub secrets. Enter HashiCorp Vault. The Vault team here at HashiCorp has written a Vault action where I can retrieve the private key data as a GitHub secret. So I spun up an instance of HCP Vault, and you can see in my test workflow how I retrieve the credentials, then decode them and export them in the steps I need. Because I needed a GCP service account and the appropriate permissions attached, I ended up setting up my Google infrastructure and my Vault roles and backends in Terraform Cloud. It took some time, but now that it's working, it's pretty slick. After that, the real work began. I began by writing resources and data sources as explained in the tutorial at learn.hashicorp.com. As most developers do, at least I hope, I did a lot of copying and pasting of previously written resources, then rewrote the attributes of the schemas to match the resource I was implementing. I'd then go into each CRUD function and replace the guts of the function with the new attributes, and any customizations specific to the resource I was working on. A big hurdle we had to address with a few of our resources was eventual consistency. And to be honest, I'm still learning how to do that best. I'm expecting we'll have changes in the future, but for now, the TLDR of our solution is that we monitor the E tag until it's changed, and as often as we've requested a change. Okay, so we prioritized our first release based on what was in the community maintained G Suite provider while adding some additional data sources. The Google provider has a very nice helper function that will reuse the schema and read functions of its associated resource, so I tried to add data sources along with the resources to be more thorough. There have been a few difficult attributes that I've had to contend with. The main one being custom schemas on the user resource. Custom schema is difficult for a few reasons, primarily because it doesn't have consistently defined fields. The user will name and define a schema in the schema resource, then reference the name of that schema and define its attributes on a block on the user resource. Attributes like this are particularly difficult because we can't validate the fields are correct on plan. In this case, I did a validation on apply, that would read the schema's fields and its associated value types, then loop through the user-defined fields to verify they were indeed on the named schema. Then we check the supplied value was the previously defined type. Due to not knowing what type the value will be, the user has to supply a JSON string for attribute values. This added some complication because the int types were unmarshaled as floats, so we had to account for that here. Ultimately, what I learned from writing the Google Workspace provider was a lot about Google and Google Workspace authentication and the difference between the two, a little about GitHub Actions, but a really neat technique to keep Google credentials secret in GitHub workflows, and some unique ways to handle validating fields with schemas defined outside the realm of the resource. I hope what I've learned from this experience will help you to create amazing Terraform providers. If you have any questions about how to contribute to any of our current providers or how to begin writing a provider from scratch, please reach out to me at mbang@hashicorp.com. Thank you.